spline curve representation. We are going to discuss about the cubic spline representation. A cubic spline curve can be represented in parametric form, as we can say that your P of u equals to a u to the power 3, b u to the power 2, c u to the power 1 plus d. This is your parametric representation of a spline curve. So to represent a curve, we may have different ways to represent different curves. Like suppose you have a straight line, we can represent using your some other formats. So this is for your understanding. So we know that we have the concept of your implicit function and the explicit function mechanism. So we are writing your function as this way: y equals to f of x. So here x is independent variable, y is a dependent variable. Suppose take an example of your equation line y equal to mx plus c. Right. So here the value of y is determined from the independent variable x, and we have represented a curve using your another approach, that is called your f of xy equals to 0. So there is no concept of dependent and independent variables. For example, you take the equation of the circle we have studied in your midpoint circle drawing algorithm and your Bresenham's circle drawing algorithm. So in that case, you are representing in this way that f of xy equals to 0, like your x square plus y square minus r square equals to your 0. You are writing in that way. Right. So we can say that this one is you are representing a line using your explicit function. Alright, explicit approach. This one is called the implicit way of representing the curve, and there is another approach that is called the parametric. In the parametric form, you are going to write that your x equals to your f of u. So here we are using a third parameter, extra parameter we are going to use. That's why it is called the parametric representation of your curve. So this is called parametric representation. So now we came to know the different way you can represent the curve. So in your spline, we are going to use your parametric format or parametric form to represent the spline curve. So here we are using a extra parameter u to represent the curve, and the degree is here 3. So that's why this is called the cubic spline curve. Now your spline curve represented in the cubic format using your parametric representation. If you have a pixel or a point in that your spline curve, how you are going to represent a point or a pixel in your spline curve? Suppose we are having a point P, alright. Suppose a point P with coordinate as x, y, z in the spline curve, can be represented as, the x coordinate is represented as your x of u. Always you will use your new parameter u to represent the x coordinate in parametric form. Then what will happen? How to write that one? So here we will write that a x u to the power 3, b subscript x u to power 3, c subscript x u to the power 2 plus ax u to the power 3, bx u to the power 2, cx u plus your d. So this is the way we have represented a point P which is having x coordinate as x of u. Similarly, the same point P, the y coordinate is represented as y of u as a y u q, b y u to the power 2, c y u plus d. Now, the z coordinate of the same point P can be written as z of u equals to your a z u to the power 3, b z u to the power 2 plus c z u plus d. So this is the way we have represented x, y, z coordinates of a point P present in your spline curve using your parametric format. So in your parametric representation of three coordinates x, y and z is represented in terms of the value of u or in terms of your parameter u. Now what is the value of u? The value of u is set between 0 to your 1. So in a spline curve, the value of u is fixed between the value 0 to 1. Now if you want to find the x coordinate value, your y coordinate value and the z coordinate value, the u value is known because it is lying between 0 to 1. So what is unknown to us? The unknowns are the coefficient, your a, b, c and d. If you can determine the value of a, b, c and d, the four coefficients if you can determine, then you can find the x coordinate value, the y coordinate value and the z coordinate value. How to find the x, y, z value? For that purpose, you are going to take the help of some mechanism. So the value of the coefficients are determined by using the Hormite interpolation. Hormite interpolation. The name of this interpolation is given as Hormite because this interpolation mechanism was developed by one French mathematician called Charles Hormite. So for determining that coefficients, Hormite had set a boundary condition. The boundary condition followed in determination for the coefficients as it is. What is that? Your P of 0 equals to your Pk, P of 1 equals to Pk plus 1, P dash 0, that is nothing, that is your derivative at 0 equals to your derivative at the kth position Pk dash, and P dash 1 equals to your value of the derivative at k plus 1. So what is Pk plus 1 and the P0 and the P1? Just think about, we are having a spline curve which looks like this way. The first control point, let's say second control point, let's say third control point, let's say your fourth control point. The first control point I am writing that P0, and the last control point that is your P1, because I know that the value of u begins from 0 and the value at the end, the value of u is set to 1. And here I can say that this may be represented as Pk, and the final value or the final control point I can write that Pk plus 1. So the boundary condition set by the Hormite is as it is. So P of 0 will be equal to P of k, and P of 1 will be Pk plus 1. And you will take the first derivative. That first derivative at 0 will be equal to your derivative at kth position, and the derivative at your u equals to 1 will be equals to the derivative at your k plus 1. Now just think about what is P. The P represents the parametric cubic point function. Now we are going to find the value of Pk plus 1, P dash k, and P dash k plus 1. So what is P? So P is your parametric cubic point function. So P is a parametric point cubic function. So we know that already we have written that P of u equals to a u to the power 3, your b u square, c times of u plus your d. Now can I find the value of P of 0? Set the value of u as 0, then what will happen? A into 0, 0, b multiplied by 0 square, that is 0, c multiplied by 0, that is 0, plus d. Now we got the value when e equals to 0, and when e equals to 1, the value will be how much? P of 1 will be a plus b plus c plus d. Now take the first derivative, that is your P dash u. How much it will be? Your 3a u to the power 2, 2b u to the power 1 plus c plus 0. Now if you find the value of P dash 0, so you set the value u as 0, so P dash 0 I can write that 0 plus 0 plus c plus 0. Now if you fix the value e equal to 1 over your first derivative on your point cubic function, so we can write that your P dash 1, just set the value of 1 at your P dash u. So I can say that here 3a plus 2b plus c plus 0. Now just look at the boundary condition. So that boundary conditions, 4 boundary conditions were written, that the equation 1, this is equation 2, let's say this is equation number 3, let's say this is your equation number 4. Now the 4 equations we are going to represent in terms of a matrix. So the Hormite interpolation boundary condition we are represented with 4 equations. Now the 4 equations will be represented in terms of a matrix. Now you set the value. Pk value equals to P0, and we got the value of P0. So now we will write that your matrix as it is, your Pk plus 1, your P dash k, and P dash k plus 1. Okay, so what is the value of Pk? If you look at here, the value of Pk is P0. And what is the value of P0? The P0 is written as it is. The P0 value we can say here 0, 0, D. P1 value is ABCD. The coefficient is 1, here is 1, here is 1, here is 1. So the P0 value is 0, 0, 0, 1. I can say that. This coefficient is 1. So your value of your P0 equals to Pk. Now we can write that, we can write here zero, 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 1, 1, 1, 1, 1. Then here I can write that 0, 0, 1, 0, 3, 2, 1, 0. So the matrix I got, so the matrix I got from the coefficients of your P0, P1, P dash U at your 0 and at your 1. So the last row of your matrix, that is 3, 2, C coefficient 1 and 0. So you can check here the same thing happened in the 3, 2, 1, 0. Similarly, your P dash K of 0 value is 0, 0, 1, 0. And when I will fix the Pk plus 1, that is your P of 1 value. When equal to 1, the value is 1, 1, 1, 1. And Pk value equals to your P of 0, and the P of 0, the coefficients I have written that 0, 0, 1. Now it will multiplied with your column matrix A, B, C, D. It will give you the value of Pk equals to P0, Pk plus 1 equals to P of 1, P dash K will be P dash 0, and the P dash K plus 1 is P dash 1. So this is the way we have represented your the boundary condition in terms of matrix. So can I write that, because I am interested for the coefficients. If you can find the coefficients, then I can represent your cubic spline curve. So how to find that ABCD? So I can write that the column matrix which is represented for your coefficient ABCD as, here I will write that Pk, can I write that Pk, Pk plus 1, P dash K and P dash K plus 1. Which will be multiplied with your inverse of this one, right? So what is the, I can write that your value of the matrix I am writing at MH, the matrix meant for your Hormite interpolation, that is M inverse, where MH equals to I can write here 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 1, 0, 3, 2, 1, 0. If you can find the inverse of your MH matrix, alright, so here simply I did that one. So you can find that ABCD value, you take the inverse, multiply it with your column matrix Pk, Pk plus 1, P dash K and Pk plus 1, it will give you the ABCD. So what is the inverse value of this one? You can write the equation as A, B, C, D, the 4 coefficients as the inverse value. The inverse value, what is the inverse value? MH inverse, what is that value? Which is multiplied with your Pk, Pk plus 1, P dash K and P dash at your K plus 1, right? So I can write that, I can write here the inverse value. So you can find by using simple inverse finding the inverse of the matrix that is known to you, you can easily do it. So directly I am writing the value 2, minus 2, 1, 1, minus 3, 3, minus 2, minus 1, 0, 0, 1, 0, 1, 0, 0, which will multiplied with your pk, pk plus 1, p dash k, p dash k plus 1. Alright. Now, this inverse you can find from your original matrix. Alright. So, that's quite easy for you. We can find that value easily. So, this is the way you can find the coefficients of your cubic spline curve. If you can find that, then you can represent a cubic spline curve using your Hormite interpolation mechanism. So this is all about representation of a cubic spline curve. So the next lecture will be on your B spline curve.